So index sequential file access. Here we see what is index sequential access used for. Here mainly we have seen that for viewing a file we have two techniques like index point of view for reading a heavy file or a large file, and then sequential point of view for sequentially accessing a file. Okay, and now the requirement is that we need both index point of view and sequential point of view to be used simultaneously. For it is used in cases that for some of our applications we require both of it. That is why we go for this technique. For a very simple example, if I need an interactive random access and a co-sequential batch processing in my application like a student record system, and there I might require both of these applications, both of these views. So that is why we go for this index sequential access. Here, the first basic thing which we need to know is how to maintain a sequence set. So what is a sequence set? A sequence set is nothing but a set of records which is ordered based upon a key, and it works the same way as when we do the addition or deletion of new records. Okay, so here we mainly try to localize things by including the concept of blocks. Okay, where whenever a block mainly contains set of records, and whenever a new record has been added, a block has been splitted, merged, or redistributed, as we have already seen in the case of a B tree. Okay, next we go for seeing what are the next other concepts which we need to keep in our mind when we include blocks. Okay, here when using blocks we must always keep a sequence set in order by key. Okay, we can tell that whenever we are, even if we are, the records are not represented as records and it is instead it is represented within a block, we have to maintain the order. Now we need to see how is it in maintaining the order. Okay, we can tell when the block has been introduced, we end up having internal fragmentation, because we have seen in the previous chapters that how a block system introduces internal as well as external fragmentation. So the same thing happens here as well. So here the physically we can tell that a file which is containing blocks are not physically in ordered sequentially. Okay, but we can tell that the blocks or the records within a block is actually ordered sequentially, or it is in an ordered manner. Okay, now this is an example which explains you how does it work. Indexed sequential access works. So this is an first one, A, which mainly explains a set of records. Here we are going to try to insert character in B and delete Davis in C. Okay, so the first example is in this list. See the list. The block 1 is having Adam, Bayar, Bixby, and Bune. So these are the set of records which my block 1 is having, and block 2 is having Bynum till Davis, and block 3 is having from Denver till Ellis. Now in case B, I am trying to insert character. For inserting character, as usual, I need to insert it after Carson. Okay, so what I need to do is I'm going to split this, and now I'm going to create two set of records or two set of blocks where Bynum Carson will be containing character as well, and the next block will be containing Coley and Davis. So now how is the connection going? From Adam or block 1 it is going to block 2, and after this is the division. So from B2 the B3 must be pointing to the divided Coley and Davis. So now the connection is going to the fourth one, that is Coley and Davis, that is a new block 4, and from block 1 block 4 it must go to Denver and Ellis. So from here the connection goes to Denver and Ellis. So this is how in addition the blocks have been splitted. Okay, now we consider the case of deletion of Davis. Okay, when we consider in this list we are going to delete Davis. So what happens when you delete Davis? Coley is the only one which happens. As we have seen in B tree, when we do the deletion and if it contains minimum number of elements, what we have to do means we have to merge with the sibling. Okay, so here the sibling is the previous, that is the block 3. Okay, so what we try to do means we try to merge the block 3 contents into block 4 and free block 3, so that because block 3 is the end block. Okay, so we try to free block 3 so that it can be reused by any other program. Okay, so now we are deleting Davis, and now Denver and Ellis is added into my block 4. So this is how you see in the addition. So into block 4, Denver and Ellis is added, and now block 3 is available for reuse. Okay, and the connection remains the same. Okay, so next we go for maintaining a sequence set. Okay, in this case, what are the other things which we have to consider? Here we have to consider the block size as well, because block is what the main content of or unit of data. So in block size, the block size must also be considered. When we consider the block size, we must consider that it contains this maximum number of records. Why? When it contains maximum number of records, in within one access, I'm able to access the whole file records. So this can be this is the first suggestion which we try to keep in our mind when we are considering blocks. And the second one is, whenever I'm doing a read or write operation, it must be in such a way that it optimizes the disk seek time. Means the utilization of my block must be in such a way that it must be nullifying the seek for seek which is taken for read or write operation. Okay, so I go for the next topic, that is adding a simple index to my sequence set. Okay, in this case I'm trying to introduce an index concept or an index file into my sequence set file. Okay, so similar to your B tree concept. Okay, I'm having with my B tree concept. So we'll see here. First itself, I'm trying that in my when I'm trying to introduce an index, I need a range. For every record, I am introducing a range, and that is used for introducing my index. Okay, so I'm trying to introduce a single index here, and we can tell the process of combining both the index and the sequence set is known as combined indexed sequential access. Okay, now we can tell that this sequence or this process is efficient, or it works well when I am considering that my index file is accommodated within my memory. Now I'm having the same problem as before. If my index file is larger than the memory, what do I do? Before we have seen that B tree was used. Now in this case, the concept of index is also been introduced. So I go for the next concept known as B plus tree index, B plus tree, where both the index and the sequential set also can be introduced. So this is how it look like. So this is my list or the file which is divided by blocks. So 1 2 3 4 5 6. Now I need to see what is the range which is used for indexing each and every blocks of my data file. So here the list is from Adam to Burr. So the maximum data or the maximum record is the larger record key is considered. Larger key is considered as my key for that particular block. So Bernie acts as a key for my block 1. Similarly here Cage acts as my key for my block 2. Similarly, the larger key of every block acts as an index here. Thank you.